All right, hello YouTube. Another day, another hard Atcoder stream, problem-solving stream, where I will struggle for around an hour or 2 hours to solve a very difficult problem. If you are a beginner, I don't really recommend to you watching this stream, because it will be very hard to keep up. On other days, I do easier contests. String ping in Discord, sure, I will do that. I remembered about it this time, but thank you. Today it will be very hard rather than hard, I would say, because we're starting from I did ABC during the previous stream. Right, Discord done. What's up, Gupta? Hi, Binary. The hitchhiker. Hi, guys. Oh, one more thing, need to encode verses to the stream. What are the names of my streams? If I notice I could do it directly from next time too. I mean, it takes me 10 seconds. Right now in Discord, I just ping hard Atcoder problems now. I don't even bother to put a link or anything like that. So then it's easy. Back after long hiatus. Yeah, like you used to be very, very active in the streams. Yeah. In the meantime, I was newbie in Code Forces. All right. So if you have any feedback about how a thumbnail should look like for these streams, because I'm very unhappy with this for the whole time. I mean, in Twitch, whatever. Just in YouTube, I think it's bad that just now I have a wall of this. It should be something else. And what you see on the left is my idea, current idea. Maybe, let's say, the second version. On purpose, this is small format because this is what you will see in YouTube. And I think it's just this plus maybe stream number, like at stream 1, stream 2, anything like that. Maybe the live red thing with like this thing to indicate that it's a live stream. I don't know. Bigger view is that. Let me know if you have any idea of how this should look like. But anyway, let's do the problem. It's related to counting or probability, I think. N people numbered from 1 to n. Okay, items. Players play in turns. Also, the link is this. Petrozavodsk camp was announced. I'm considering participating, but like it's always good problems, good system, and it's very cheap. But I don't think I want to participate in all the contests. If I get to agree with my friends that I will participate for half of the camp, like for maybe 5 contest days, I would be very happy with that. I don't want to do every single contest, and then all the absolving is annoying too. I used to do that, of course, when I wanted to practice for ICPC. I don't really want to spend like more than 100 hours. Starting with the yes, because why don't I have? Oh yeah, I have chat. Right. I love when you say Gupta. I guess it's Gapta or what? Gupta. Why did it disappear? What happened? Maybe it triggers when somebody writes something. It's very strange that it refreshed completely. Test 1, 2, 3. Are you doing Quora challenge? Oh, is it soon? I don't see it. I saw the announcement somewhere. Anyway, if I have time, then yeah, I will participate, assuming that I'm allowed to do so. Let's do the problem. Hi, Manon. If the person already wins an item, nothing happens. I don't know what that means. He chooses one of the items he hasn't chosen yet, uniformly at random. And secretly tells it to snook. So wins just means gets an item. All right, so person 1 will get one of the K items, for sure. Then person 2 chooses a random item, and if it's available, then he gets it. And so on. Why is this game not infinite? Hi, Malcolm. And Mianix. Hi, guys. Welcome to the stream. Though, disclaimer, this is a very difficult stream. I will solve very hard problems. All right, I understand the statement. Oh, what happened? Don't get why sometimes Windows doesn't catch this yet. Right now, I cannot move them both at the same time. Oh, OneNote doesn't want to be wider than half the screen. Strange. Do you have a problem in OneNote when Control-Z sometimes doesn't work? I don't. It only happens when I use some other software that catches Control-Z, captures, like Epic Pen. Epic Pen is the other software I use to draw like kind of on the top of my screen over other applications. And the Control-Z there captures all the Control-Z. As long as that program is on, I cannot use Control-Z in anywhere else. It's a bit annoying. Okay, let's say k equal to 3. N can be higher. Person 1 will for sure win an item. And then we can say that person 1 won. This person won. Then person 2, with some probability, will get an item, one of those two. Doesn't matter which one. But with probability 1/3, 2 will try to get 1, and then nothing will happen. And so on and so on. Let's say that 4 got some item, like that. But arrows, they don't matter. For 1, let's say that 5 also got 1 or 2. Now in the second run, 2, 3, and 5, they said that every player takes a random item out of those he didn't try yet. So if in the first run 2 tried 1, then now 2 will try 2 or 3. I think that what matters is only the current turn. If the current turn is, let's say, 2, it means that every player already tried 1 item. So for him, he thinks that there are k-1 available items, like for a 2. 2 tried 1. So now 2 will be left with a choice between 2 and 3. There are n-1, or in general, n minus turn -1 available items. He will choose one of them. And with some probability he will take it and then win. So for a 2 situation is like that. There are this n minus turn -1 available items. Out of them, one of them is good, because there were already 2 winners, so they killed 2 items, and that's it. How can we describe the situation? With some kind of DP maybe? I guess it's the current turn, the number of winners, those guys. This is equal to the number of killed elements here. And that's it after a full turn. But when they told me to find the probability for every person that person wins an item. Like this, maybe I could already compute expected value of the time of this game, how long it will go. But because I need to focus and compute probability for a particular guy, then I would say that I need to know the number of winners before and number of winners after. Maybe this is actually 2 values, like W1, W2. Assuming that person I'm looking at didn't yet win. Did you delete some videos from Algo stream playlist? No, I didn't. Successful, right? So was stream off? It wasn't just you, I think it was everybody. But what's cool is that OBS now warned me about this with a notification with sound. It used to be the case that sometimes I would need like a minute or two to notice it. Release up to 40, right? But we are not given modulo in the input. Instead, I can process everything on my own computer. So if I get solution with n to 6 power complexity, I'm good. That's promising. But then also I'm worried that maybe I get something wrong. Maybe there's some state I'm missing. I don't think so. I expected a harder problem though, so something must be wrong. N minus, what is this? Oh, this should be K. If this is turn T, then that many numbers I already tried, and K minus this is number of available items. So I can use this information, also W1 plus W2, to know how many possibilities I have. Actually, do I need this split or not? I don't think so. No, I think so. There is difference between elements on the left and on the right. And always I will assume, let's say that here n was 5. Let's say that n is bigger. We are looking at this particular value, say 4. This is important for us. Then if w1 is equal to 1 and w2 is equal to 3, there's one winner on the left and 3 winners on the right. I think it doesn't hurt to assume that this winner is prefix of those two parts. Those are winners already, and they are still in the game. And also I am. As I go through this, maybe then I don't need new W in DP. I can just increase W1 and W2 as I go. I will consider this I. It will be a winner or not. If it's a winner, then I will increase W1 by 1. Seems good. If that's the case, then I will have just simply this. I missed something. DP of current turn, W1, W2, and I. Do you see any issues? If no, then I need to code it. Also, what will DP denote? Probability or expected value? I think it will be just probability that I get to this state. And whenever I see I, and I see, oh, there's probability, say 0.02, that I'm here at turn 5, I will add 0.02 to the answer for this guy, for his expected time. No, sorry, we just care about probability of winning, not any expected time. I tried to solve a harder problem. When I get here, oh, just whenever I look at I and I see that with probability 0.02, I got to this state, and now I have probability, say, 3/7 for some reason, that this guy wins right now, then answer for this guy will be increased by that. Answer of I plus equal the product. Sounds simple. I don't know. This doesn't even require preprocessing on my computer, so. And there is a big time limit here. I have just n to 4th power, right? This is up to k. Those two are up to n. Also, there's sum doesn't exceed n, so it's even lower. I is up to n. Otherwise, the guy wins or not. The limit of 40 strongly suggests some meet in the middle, where I split them into two groups, and it will be 2 at power n over 2. Right. I will ask you for a favor. Please, somebody, go to editorial and tell me if the solution is indeed polynomial. It is indeed like n to 4th or 5th power. I'm worried that the solution is actually exponential. like maybe 2 at power n over 2. And then I for sure got something wrong. Tell me if it's polynomial. I don't want to see the editorial to spoil to myself and all of you the whole solution if I'm wrong. It's polynomial? All right, cool. Thank you all. Let's go. I don't know if I already complained about this, but after I updated Ubuntu, it was just, like once every week or so, it asks you to update. The resolution got messed up. Yours is actually shorter than that. I guess you mean that my solution is faster, and then I'm a little bit worried. Right? Wait. I don't remember if I was coding something confidential. I will open Atcoder here as well in the virtual machine. Will be a bit more convenient. Sample tests explain stuff with probabilities like this. So I can just use doubles. I strongly prefer using doubles when implementing stuff like that, because if I get samples wrong and I will get a randomish value, it's so hard to debug with stuff modulo mod. Please beat William Lean. How should I beat him? Change driver in software updates, additional drivers, maybe after stream. Please tell me that in Discord after the stream. I can try. I spent some time on this and I couldn't get it work other than just to make some script that will be run at the beginning, like when I run virtual machine. But it's annoying if it will be again messed up after the next update. Right. What do we have? Double. This is the P of current turn, probability that we get to the state. Current turn, I, W1, W2. Oh, and we need to do it for every person. I will have n to the fourth power. Oh, so n to fourth power for every person. That's n to fifth power at total. Actually, there is k somewhere here. Like this doesn't exceed k, but whatever. Right, that's the plan. Should I number them from 0? Sounds fine. There's some completely different like DPs run for every person. I don't care about speeding this up. Even if this turns out to be n to 7th power, that's fine. I will let it run for 10 minutes or just maybe I will need to speed this up times 3. Have you tried applying at Google? I mean, Google invited me for interviews. I didn't try to get there. By who we mean this special person. a person for whom we want to compute the answer. Let's start from turn 0, why not? Let's number turns from 0 or 1. 0, let's say. And also people will be numbered from 0. There is this probability. Start here also to do, how to do it, memset. dp 0 size of dp. Is this how to do it? Please tell me if I'm wrong, to fill all of that with zeros. Turn is up to k, I believe. After k turns, everybody tried already everything. Sonar Gonul, thank you for the rate, if that's what this is. Anyway, thank you. I just saw a comment. Hello, have a great stream. If you don't know, Sonar Gonul streams coding game short challenges very often, around the same time when I stream. For every I, for W1, W1 will not exceed who? Let's see an example. If there, let's say the special who person is here, so this is 3, that there are 3 people on the left, and this will be what, n minus who minus 1. In this case, 8 minus 3 minus 1. The left part size is 3, the right part size is 4. There can be at most that many winners on the left. And that many on the right. This is probability that I win, that I get to this state, not that I win. If this is 0, then don't do anything. This is hard stream to get many viewers. Yes, of course. This is hard stream. Should I maybe move this to some other place? Displaying chat in bottom right corner doesn't work well with terminal here, but I don't want to have it on the right if I have statement on the other part. So I don't think there's anything I can do here. This can be black background, but I don't really use this terminal. Yeah, it will stay like that. And now we need to compute some probabilities. All right, we look at some person. If I is smaller than W1, or this person is in the right part, in this one, and your ID here is smaller than W2. I believe that in those cases, this person already won. Not continue. No. It's T, I plus 1, W1, W2. Assuming that I something. If I is equal n minus 1, then move to the next row, else this. This person already won. Otherwise, we need to compute probability that he will win right now. And there k minus available item for him available for me is k minus t. Like in the second turn, I'm already after 2 turns, so I chose 2 items, and only among remaining k minus 2 I need to choose. Right. Winning items are, or maybe not. Possible wins or possible loses. Loses is W1 plus W2. That many items are already taken by somebody, but I don't know about it yet. Oh, wait. Is it important that some... Well, I think it's important was the intersection of those two, isn't it? If yes, then my solution is completely wrong. Move it on top left. Are you sure it's part of the code? I don't feel convinced. Because look, I don't think we need, I don't think we want that. Actually, in bottom right, at least nothing is happening. Top right. Thank you, Kashubki. Beautiful. Like that. That's the best layout. Yeah, I'm not going to move it like once I open Atcoder. Yeah, great. Wait, actually it's a bit too small. We need to do this like that. No, now it's beautiful. All right. If indeed the correlation between them, or the intersection size, is important, then I'm screwed. I wanted to say this. Let's say that there are 10 items. If 3 of them are not longer available because they were lost, like they were won by somebody else. Also, these 2, so available for me is 8. I choose out of 8 items. Oh no, wait, it's fine. The fact that I tried 2 items, it just means that they were already won by somebody else. So I don't know that 2 belongs to those 3. So my probability of winning here, or probability of hitting wrong here, is 1/8. Among 3 items that were already won by somebody, I tried already 2 of them. So everything is fine. Probability of losing for me now is 3 minus 2, which is loses minus t divided by, what is 8 available for me. Otherwise I'm winning. If I is who, actually don't I compute the answer for everybody here? Oh no, because I have this strange thing about W1 and W2. Make chat messages black too? Oh, it will be hard. You know what I can do? Oh yeah, I can move this background transparent thing above the chat, if you like it more. Also, I can make my face to be above the chat, but I'm not going to. Right, now it should be normal. But if you prefer this way, I'm fine with that. Should I use my time watching your previous streams or just being regular from today? You don't need to watch all streams if you have that much time. But remember that you need to practice by solving problems yourself too. Don't assume that watching me for 50 hours I don't think that watching me for 50 hours is that much better than watching me for 2 hours. For 2 hours, you can already see some thinking process. I would recommend to everybody to watch me for some time, but not for sure, not to everybody, to watch me for like 50 hours. It's not that you need to binge watch all the streams. Unless you like background noise, then sure. If this is the special person, then take the answer. Else, we're just moving to a new state, right? dp of... Oh, I will need the same kind of if. That's annoying. Let's try to make this like one-liner. I equal to n minus 1. Plus 1 modulo n. Yeah, this should be good. Should be good. So we have this. Where is it that I'm winning? And now if I'm smaller than who, then there, increase one of those two winning counts. All right, this is to consider the situation when I'm winning. This is why I multiplied by y minus p losing. So now consider me winning now. Consider me losing now. This was just notes, drafts. All right, consider me losing. We just move to the next state and nothing changes, I think. And to solve what's wrong. One 3/4, 1/4. Good. No, into doesn't exist. Uh, 47 divided by 54. That's correct. 77. I'm just comparing my values here to the values they said the answers should be. Correct. Correct. Well, great then. But that sometimes it hurts. If you solve a problem fast, you're not sure if the solution might be that easy. In Atcoder, usually problems, they are so hard. Just, I thought that something is wrong, and I wasted a few minutes thinking that something is wrong, that I'm missing something. It's good to be confident, but of course in competitive programming you need to think, well, if my solution is that easy for a hard problem, maybe I did a mistake. Hi, Veyman. What age I started coding? 10 years ago. 6, maybe around that. When I was 16 or 15. Let's copy this. I still don't have any struct for modular computations, and I do it by hand every time, which is annoying, and I need eventually to make this struct. Now we need to do stuff modulo this. Right, this computes modular inverse, multiplies two numbers. That's, I guess, most of what I need. Okay, this, we have that. Loses, that can be negative? No, it cannot. Multiply this by the inverse of that to get the division. Need to add here, add there. Oh, there's also a subtraction. Right, now we are good other than adding in multiple places. Just adding is wrong. Yep, and for that, good old add self. That will simulate a plus equal b. With an if instead of modulo operator because it's faster this way. Actually, I could just say answer becomes answer plus me times tmp and all of that taken once modulo mod, and it would be even better. It's a very small difference. Should mainly focus on complexity, and then second thing to focus on is not to use modulo operator too many times. Three, 1, 4, 3, 1, 4, cool. Let's make a diff between my output and theirs. Right, everything works. Let's measure the time for max test. I don't know if that's a max test. Maybe. Have a second on my computer, then it's good enough. I don't even need to remember all the values. Don't understand 80% of your works, but why I spent time watching you, I don't know. I don't know either. So is it entertaining or just, I don't know what else. It still might be educational even if you don't know everything. Yes, module operation is computationally expensive. Hi Kaszubki again. Right. Well, we are done with D quite fast, so let's try another problem. And I think that E was impossible to do. Yeah, nobody solved E, so no thank you. By the way, what were times of people for D? 20 minutes? Yeah, that's fine. I got 40 minutes while talking and explaining and thinking what's wrong here. So by this point in the competition, I would see that other people solve it in 20 minutes, so I wouldn't postpone it so much, thinking that something must be wrong. Are you sure it's correct? Yes, I am pretty sure. What? You break it up after getting a 0? What? Instead of continuing? Wait, what? No, I'm not. I'm continuing, not breaking. Weak tests. 80 line. Let's continue, not break. If you get the state with probability 0, then you can continue. But yeah, if it was a break, then that would be wrong. Right, NAND tree. By the way, the speed is not, constant optimization is not the only thing to do this. When you make all these transitions, when you when you increase something by +1, in many DP you might get out of boundary error if you try to get to impossible state. Like let's say this. If I defined my DP array as exactly 40 by 40, but when I'm at turn 39, I try to do DP of t+1 plus equal my current state times some probability, then I will get out of boundary error for t equal to 39, if the array just has elements up to 39. But the cool thing about this continue is I will never consider going to impossible states. Actually, I would need something stronger for that. And sometimes you need it. When moving from my current state to a new one, like with this, what I actually should do is only if this probability of going there is non-zero, my state is non-zero probability and going there is also non-zero probability, then do this line. And then do this line. Only then you're guaranteed that you will touch in DP only states that are really possible. And you will not try something like DP of max t+1. Then, till the end of the stream, we'll try this F problem. Where's my link thing? There is a tree. There are edges with labels. Repeat the following operation on the tree. Contract an edge. Take NAND, not AND, of the two labels of vertices. Oh, so okay, I thought that edges have labels. No, vertices have some numbers written in them. Edges do not. Compute the answer modulo 2. In particular, that's very important. Some very hard problems ask you to compute the answer modulo 2. It means that if you see two symmetrical ways to move forward, you can ignore both of them because they cancel. Editorial solution is n to 6 power? Really? I had very easy in 5th. Where's editorial? Shopping? Right? I had 5th. 4 for loops, and that's it. Run for every person. In the next turn, okay, I think they move turn by turn instead of one by one. Well, whatever, they overcomplicated it. Which happens a lot in Atcoder, mainly because Atcoder has some very hard problems, I believe. I need to do one thing. Feel free. I'm just modifying something in displaying the chat. Now maybe it will not disappear. I'm not sure. Right. My first idea is that if two edges do not touch each other, I don't need to consider taking one of them and then the other. When we just care about the parity of the answer, then let's say we have this. We have that again. When I, let's say, contract this edge first, and then this one a second, versus I do this one first, this one second, I will get the same tree, and the sum over possibilities over this and that, it will be the same. And because I just care about the parity of the answer, I can ignore those two possibilities. Which means, I almost want to say that I should just consider cases where no two edges are adjacent. Sorry, where every two edges, consecutive edges are adjacent. An example of it will be 1, 2, 3, 4, 5, 6, 7. So I think that a tree must look like that, or otherwise the answer will be 0. I guess you can call it a caterpillar. And in this, solution must look like this. Some order of this, 6, then 7, then some order of those, as 8 and so on, up to what, 8, 9, 10, 11, 12. Then this is exactly 13. Then those. Oh wait, okay. I also shrink stuff. Let's not forget about it. But I mean, I can still imagine that the drawing is just like it starts, right? I can imagine that drawing doesn't really shrink. But whenever something happens with an edge, actually, there is some new drawing that says what exactly should be done. Is there a tree in the input that doesn't look like this, and the answer is still 1? Awesome. Usually Atcoder is nice because of strong sample tests, but here it's just terrible. You have yes, no answer, like 0, 1, and there are only 3 tests. 2 of them are so small. I hope that I'm not wrong here. Tell me if you think that I did something wrong. Now, we want to count cases where at the end initial numbers are 0 or 1 or bigger, 0 and 0 or 1. Every time I take NAND, Depending on the order of these operations, what happens? I will skip this part, but after it, yeah, after this initial part, I will have some new value here, then this. I'm drawing the same tree, just after resolving contraction here on the left. There is some new value v there, either 0 or 1. Then depending on order of dealing with stuff there, well, then v is merged with this guy. So there is here some new value v. And then, depending on order of dealing stuff with this, I might get here a 0 or 1. It seems that and maybe there's also some symmetricity here. If each value there is only 0 or 1, I might do some small dp. If v starts as 0, after I'm done contracting the left part, then dp of ab would be the number of ways, or only its parity. And to get this new value v, this is 0 or 1. After I took that many zeros and that many ones, or something like that, so only use this, use this, use that. I only care how many zeros and ones I used among those 5 items. Then what's the new value v? How many ways there are to choose that many zeros, that many ones among of 5 possible elements, and get this current value of v. This would be too simple, I would say. Suspiciously simple. What if you have edges A, B, B, C, C, D and start with BC? Can you really swap A, B and CD? Can I? If I start by shrinking the middle one, then I will have A, this is some new value V, this is D. What I claim is actually this. If we start with CD, and after that the second operation will be to shrink AB, then I can swap these two elements because I will get the same thing at the end. So I claim that I don't need to count this order because it will give me the same answer as this order. Those two, I don't care. What I need to count though is situations where I start with this guy, then second, then third indeed. So at the very beginning, like the first two operations, they cannot be for two different edges in a tree, I mean, not adjacent edges. But this example indeed shows that it isn't correct to say every two consecutive operations I make are for non-adjacent edges. Or I claim that it's for adjacent edges. And this implied the tree must look like this. Yeah, this is a counterexample to my logic. So thank you, Maxim. Even if it's a line, I think that the situation will be quite complicated. I don't want to touch the chat. Is it that we will start from somewhere and then we'll go in two directions, expanding from the middle? So for a chain, tree being a chain, I would guess that we'll have some kind of DP of L, R, and V. The number of ways to shrink interval from L to R into a single value V. But then should I first do some interval and then the other? No, because then I can do this. Hello, Pancetta, Concetta. Hi, welcome to the stream. Fortunately, this is still polynomial for a chain. But what will happen if it's not a chain? In particular, can we have something more complicated than this drawing? Let's try that. Let's say that I first do this edge. Can I do something like that? After those three operations, I will have this thing, and then I think that we need to consider every order. Well, that's bad. Because we can also apply this logic to say that this tree might have answer 1. I think. I'm not sure. The answer is asked modulo 2. So again, if I see some symmetricity between two cases, I can ignore both of them. I forgot how useless samples are. What tablet? Wacom, I don't know, some small Wacom tablet. You will find, not this, you will find information there. Along with a model. I will try to get this the two windows to be same size. Now it should do. It should work. Right. Printing answer model 2. Isn't it possible to easily pass tests with a randomized algorithm? How will you do that? While practicing, yes, it is possible, but not. I don't like the fact how chat is cut a little bit. During a contest, remember that tests are scrambled and you don't see, for example, test 2 answer is wrong, right? So during a contest, you cannot use some tricks. Some platforms are better for that, like in Codeforces, you see what happens for every particular test. But not in Atcoder, at least not during a contest. Do I have... I think I have something on my screen. What's going on? I don't know. There's some pixel that annoys me. Also, if there are 50 tests and you just submit rand modulo 2, then you will need around 2 to 50th power tests, runs to get it right. Couldn't even understand the editorial? I don't know your rating. But obviously, if problem is much above your skills, then you are likely not to understand the editorial. Basically, I don't recommend solving problems that you cannot comprehend the solution to. That's a waste of time. Mostly. It's good to, from time to time, to be devastated by a problem. It just shows you that you have still a lot to learn. I'm looking at this Y example and seeing if maybe there is some symmetricity. I still didn't use any properties of NAND. I understand why they didn't choose AND or XOR or anything like that, because maybe that would be easier to handle. Like AND of everything just checks if there's any zero, or of everything checks if there's any one. I don't know if XOR is that easy. Is it true that we just take XOR of all elements? Yes, it is true. All right, so NAND is the simplest thing that they could do. Simplest function computed onto arguments that we cannot easily compute given n elements because the order matters. I don't know those words like commutative and so on. There are some words to describe operations. This is the only operation where it depends on the order of stuff. Not order of two arguments, but order of three. Resolution, I don't know what that is. Oh, resolution. Yeah, you can watch on YouTube if you want. YouTube, this is alternative way to watch, and you can watch in lower resolution there. Also, don't use caps lock. If somebody here in the chat knows a solution, please tell me if I should investigate properties of NAND. Or could it be kind of arbitrary function? And I'm still looking at this to hopefully say that, oh, if we do 1, 3, 2, it's the same. For two edges, if I do one after the other, I want them to touch each other right now in a new tree. I wonder if we can even do 1, 2, 3, 4, 5, 6. I don't see why not. Should we maybe look at some subtree? Let's say we root a tree here. I don't know if it makes any sense, but we root it there and we look at subtrees. Should I now look at this subtree and say that every next operation, it just puts some vertex here, merges it with a root. Oh yeah, we can just say that. I think we can. We have root of a tree. And always what we merged into one vertex is some kind of connected subgraph. Like maybe this. This all merged into this guy. And then one of those edges I can now shrink, contract one of these. If that's the case, then every subtree will give me some order of values. Like when I first use this edge, it will give me from this bottom vertex 0 or 1. Then I use one of these two, and it will give me 0 or 1. This gives exponential number of possible sequences. The size of this sequence is equal to size of a subtree. Maybe this order is possible. Maybe this order is possible. If some order is possible even number of times, I can ignore it. It's an exponential solution, but I can merge two subtrees by interleaving their binary subsequences, by interleaving their binary sequences. Don't expect me to, very quickly solve this problem. It was hard. During a contest, only 3 people did it. And it took them around an hour. I don't even remember now. Let's check. Three people solved it. The competition was more than 3 hours. This problem took everybody more than an hour. More like 2 hours on average. So for sure I will need help from editorial if I want to solve it today. Right. Let's try to analyze what NAND does. Maybe some sequences leave the same, will give me the same final value. If there is 0, and then I NAND it with 0, then NAND it with 0, let's say, what do we have? This is for sure 1. Basically, anything and then 0 is 1. Because it's not AND. When I write, let's say 0, 1, 0, let's say when I write this, I mean NAND of 0, 1, then NAND of this answer and this result and 0, then NAND of this and 1. So I NAND values 1 by 1. Anything with a 0 is 1. 1, 1 will give us 0. This is 1. Just once will give you a 0, right? 0, 1. 0, 0, 1 is what? 1, 1. Not AND. Basically everything other than 1, 1 everything other than 1, 1. So, I mean, this case is stronger than that. And maybe there is some symmetricity here. Like for 3 elements. If the last use thing will be 0, then, well, the order of this doesn't matter. So I guess I should assume that the last one is 1. Code forces or Atcoder? Code forces is more like neutral. It will give you variety of topics. Atcoder is good for pros, for people who want just interesting mathy problems. What resources I used? All the resources. Code forces, Google, everything. Practice problem, read tutorials. So AB0 and BA0 are symmetrical. What about AB1 and BA1? Are symmetrical as well, right? Because if it's 1, 1, then, well, it doesn't matter. If anything else, then both will give you 0. That might be important property of NAND. Something, no, A, B, whatever, and BAX are symmetrical. What does it really mean? What does it mean? I almost want to say that if this logic was right, that we should choose some kind of root, and then everything will be merged into root, then this means that everything other than the last two elements, the order of those is not important. So we can simulate everything basically in any order. with exception of what is the last element. Everything other than the last element we can do in any order. I want to check this lemma with code. Every element I take NAND of what I have so far. And the claim is let's just try a random sequence. When I random shuffle everything other than the last element, it's the same value. Let's print n. Just let's print something to see that something's going on. Nope. Assert failed. Did I implement correctly? We start with a 0, then not end. Here it should be true. Here it isn't. It is true for 3 elements. Isn't true for 4. Why? Oh, I think I see. We have 4 elements and we compute NAND in this order. If we swap A and B, we don't change the answer because this will still be the same. But if we swap B and C, then something random-ish will happen. Then we'll take a C, then we'll take that with B. Yeah. Right. For arbitrary n, we can random shuffle only the first 2 elements. Assuming that n is at least. Yes, this is true. How did it happen that in Twitch chat I don't see math? Oh no, sorry, never mind. Okay, I missed some message. What topic is going on? I don't like math but want to learn. Well, you can learn math. In just Google Codeforces how to learn math or something like that. I am sure there are a lot of tutorials of math for programmers. Right, so the first 2, they do not matter. But isn't this still very important? I think that it's still crucial because when somebody tells you that for sure merging this in this order, Oh yeah, the first two, they don't matter because the first two, they just represent two endpoints of the same edge. Okay, so that's nothing. The important thing is when we have three elements like ABC, it's about contracting AB first and then adding C versus contracting BC and then adding A. And I'm sure that can be different in some case. For example, what? 001 versus 001. In this first case, this will become 1, then this will be 0. In this other case, this is 1, and anyway, anything with 0, this will be 1. The order of doing stuff here matters. Speedrun of new CSCS problems? I don't think that's beneficial. I don't like speedruns. Speedruns are for entertainment instead of like they don't really have educational value. Why do you want me to solve problems fast? I did that in the past. In terms of flexing, I already did that. I can take 2 or 3 interesting problems and talk about them and try to show you a solution well with drawings. I don't know. I have mixed feelings about speedruns. Still, just for the views, it's not a bad idea. Does somebody here know a solution and can tell me which direction to go? In CSCS, they added like 50 or 10 or 100 problems. This is enough for tens of videos, to be honest. CSCS worth the time and effort? Yes, if you don't mind the lack of editorials. 100 problems. Okay, so 100 problems is a lot. Explaining a problem well is at least 10 minutes. That's 1000 minutes. Just arrived reading the task? Yeah, then good luck. But don't worry, it's not that I'm finishing anytime soon. I don't know a solution. Learned persistent seg tree from William Lin's CSES speedrun. So in the middle of a speedrun, he explained persistent segment tree? Really? If yes, then his speedrun would be very long. Okay, so it's just that you learned about the existence of persistent segment tree, then sure, but you can as well, see 100 problems and just open a tutorial for each of them for a few seconds and see, oh, this is the topic used. Probably about implementation. Then same thing. Take 100 Codeforces problems, open submissions by people in the top. That's completely different than explaining a problem. I'm not saying no. I'm not saying that I will not do any speedrun. Maybe I will do at least CSCS geometry section. So this was useless. All right. Time to read the first sentence from the editorial. In particular, because I know from standings how difficult this problem must be. I'm making this huge in order not to see everything after this. First, right. Suppose that we first perform an operation on edge E1, then edge E2. I have that. The only exception happens when E1, E2 share a vertex in common. We assume that first two operations are performed on adjacent edges. I did that. There are two ways to perform two operations on part XYZ. I mean, if this is a sequence, then yeah, but all right. I will try to... I think they hint at the fact that depending on what is happening there... Oh, they just mean two edges. I don't know what they want to say, but let's try to analyze ourselves. Here I found an example of a difference, but let's see all the possible cases. If this is 0, 0, 0, then it doesn't matter if I do this and then that or the other way around. Same if, so this is whatever. I mean, oh yeah, this is symmetrical. I don't need to care about two different orders. Here, same stuff. Forget about it. This and then that is the same as this and then that. Right? For 0, 0, 1, there is a difference. We analyzed it here. So we are sad about this, but yeah, we need to consider it. So for same reason, we will for sure consider 1, 0, 0. Taking this will give us 1 and then this will give us 0, or this is 1 and then with this is still 1. This is sad face, we need to consider it. 0, 1, 0. Well, this is symmetrical, so whatever. For same reason, 1, 0, 1. But what about that? If we do this, that's 0. With that, it's 1. Then this is 1, with that 0. We need to consider. And for same reason, we need to consider that. All the cases where there are exactly two zeros or exactly two ones. No, not those. Not those, because here we have symmetrical cases. Those are cases where first and third element are different. Out of all 8 possibilities, sad green face is exactly if first and third element are different, not the same. Have you ever solved DP problem recursively during the contest? Yes. Many Indians here? Yeah, if you look at Codeforce's stat, more than half of new accounts are Indian, I believe. Which also makes some strange situation, because there are so many of them, so a lot of newbie, just bad questions and new issues, problems will be posted by people from India, and this will give everybody perception that people from India spam, for example. And that's a bad, just a faulty perception because of a lot of new users from India in Codeforces. So what do I do with this? Maybe I should also write what happens with this order. Well, actually what happens is if I have this and I say we do one edge and then the other, then in all those cases should be treated as one case, where just we can get 0 or we can get 1. If there is one possibility to do stuff and then you will get 0, 0, 1, and then the other possibility and then you will get like this or that, those two cases are the same. Each of those 4 sad green face cases gives us the same things in the future. Why no Indian in top 10? Yeah. You can try to get to top 10 if you're from India. There are too many of them. Yeah, I think it's because of some political situation, maybe not social, where a lot of people get internet access, and also a lot of people want to get jobs, so they try competitive programming. This means that if we have a chain and some interval got down to a single value, this just got to 0 or 1, then the only possibility for me to consider in the future is that there are two ways to handle that. One of them will give us 0 and the other will give us 1. Either this, or we can say that we don't need to consider anything anymore because stuff is symmetric. In particular, if there are 3 vertices in this blue thing and they are 1, 0, 0, then it's exactly this. There is one way to get 0, one way to get 1 out of this interval. Nobody's very, very, very good. To get somebody very good, you need strong education. You need to practice from very young age. You need to have parents and or teachers who are very good. If you take away all talented, let's say, chess players right now from Russia, then it's not that new children will be very good. They will not have teachers. Eastern Europe is historically very strong in math, chess, physics, and it is a circle, where a cycle. Because of teachers and parents now, new children will also be good at that. Right, if this is 0, 1 or 1, and then we merge that with, let's say, this guy. What does it mean to merge with this guy? Well, if this is 0, then we don't need to consider that. If this is 1, then doing this will again give us 0 or 1, depending on this. One way to get 0, one way to get 1. This means very easy transitions for DP on intervals if the tree is a chain. Why Russians almost always win ICPC? Because they are very good at it. What do you want to hear? They have strong teachers and a lot of interest in programming, so new children will often try programming and they will also be good. As simple as that. Notice that ICPC is often won by one of 2 universities, maybe 3. So apparently there is a strong community in those few universities and strong teachers. What's wrong with USA? Is there something wrong with USA? USA is also very strong. USA has around 1 team who is as good as a strong Russian team. But there are other aspects like money factor. If you are born in USA, you don't have that big of incentive to do programming. If you are born in Russia, also maybe in Poland, if you choose programming, you will live much better life than doing some other random job because you will earn much more. In USA, you are anyway set. It's easier to live a rich life in USA. So more people will try programming in Russia or India or Poland than in USA. Can I say something now about this thing? The first time when I hit a 0, everything so far becomes not important. If I know that the value here is 0, then no matter how I got here, let's say this is the current contracted part, all of this will become 1, because NANDing anything with 0 will give you a 1. So maybe in every subtree I need to find the furthest 0. Let's say this is 0, this is 0, and this is 0. And then what matters is the moment when I get to the last of them, and then the number of ones that are left. Let's make a more general drawing. This is the root. Have some stuff. We only care about zeros such that, so if 0 is here, then I don't care about other zeros on the path to the root. There's those bottommost zeros in some way. Then below them there are some small subtrees of ones. And now I care about the first moment when I have everything taken to all those bottommost zeros, and maybe a little bit more. And then this is the first moment when I touch the last of those, and then all of this green part will become 1, and I care about the parity of remaining ones, so remaining number of vertices in red parts. The red parts, they have only ones. This became a completely new problem. Germany is very weak in IOI. Like, I don't know educational system of every country. I will not tell you why Germany isn't winning IOI. Maybe same thing about money incentive. You need a poor country with good enough math teachers, let's say, and obviously internet access. Knowing English, I think that knowing English should help as well. Platform book for beginners. I mentioned something there. This is my advice, and it mentions nice PDF. Handbook for competitive programmers handbook. It's good for beginners. Okay, with this new interpretation, maybe we'll do something like that. There is a root, and let's say 3 children. Each of them is of form like this. each of them has some bottommost zeros, and below them red subtrees. The question will now become something like this. How many ways there are to choose a subtree of this, I mean a connected subgraph, the count of those green vertices, and also the count, or actually parity, of red vertices. Those are ones that are below bottommost zeros. No, not that. This is like one thing. Green part needs to kill everything. Okay, I care about size of green part because I will use some binomial coefficients to merge them. Like if I know how many elements are here, if I know how many are here, then I use binomial coefficients to know how many ways there are to do both. I start from the root and always I eat some available vertex. First, it's one of the three children. And to know what's the number of ways to get to this situation, I need to know the number of ways to get to this situation, times binomial coefficient size of that, choose one of them. Now, parity of green will tell me how many red things are there, because red is everything not green. And I have a requirement that every zero must be covered, except for one that I just touch. So maybe it's dp of green and also a 2. Whether I covered all zeros or maybe all but one. Then I think I can quite easily merge two children into one. All of this in total would be n squared. But it's n squared for every root of the tree. So we're looking at n cubic. Road to ROI, Russian Olympiad. Thank you, Board Slayer. This looks good. Complexity is fine. Code will be not difficult. Should I actually care about 0 being here or not? No. For every tree, I need to know if it's full of ones. If there is, or just for all of them? If there is at least 1 0 in at least one child, then I don't care about the value here, because I know that, well, I need to get there, and when I get there, the total merged value will become 1. If there's 0 here, I don't care about your value. If all those are ones, everything is 1, then in this case, I care about your value. But this should be quite easy. Now, let's think what exactly it will be. Russian Olympiad is my dream. Then practice hard, and you will achieve it. Probably. Nothing is certain. I actually, so the high school has 3 grades in Poland, first, second, and third. I tried 3 times to get to finals of Polish Olympiad. In first grade, I didn't succeed. Second grade, didn't succeed. And only in the third and final grade, I got to the finals. It wasn't easy. Yes, Kier, like you're asking too many questions not related to the stream. You can use Discord for that. So what's the requirement? The requirement is that I don't leave any zero below. This last dimension means how many zeros I left. But if this is 1, if this dimension is 1, it means that I left exactly 1 0, but I took element just above it. If there is a 0 here, then I took for sure parent of 0. In particular, if there is 0 here, and there then ones at the bottom, I can not take it, it's fine, just then I will need to take U. So if there is at least 1 0 here, I need to take U. If they're all ones, I don't need to take U. That's the logic. And now the thing with, I never know with Atcoder problems, should I now implement a solution, think about it more, or just look at editorial to confirm that this is the solution? I'm simply not sure if this is correct. I'm too scared that I missed something. I will consider every first edge, and that will give me a root. Right? Or should I consider every first vertex? That's, I think, bad. There is some first edge that will be used, and I don't want to consider AB and BA separately orders, because then always I will get answer 0. Oh, and we are 2 hours into the stream. I didn't want to stream for more than 2 hours. Should I really implement this? How long will it take? Well, let's try. What's going on? I thought that it froze. You'll try it. Yeah, like, actually, I prefer to keep my streams down to 2 hours. But I went this far here, and I hope that I got it correctly. The solution, I mean. So let's try. And we read the initial value. I checked recently if maybe in OBS there is an option to detect that some program is full screen and then to do something, but I didn't find such a feature. It would be nice though, because then maybe, like, If Ginny is on the right side, I would want to move the chat to somewhere else. Stuff like that. We can make exceptions one time. I keep making those exceptions. My Atcoder streams are almost always longer than 2 hours. I think so, at least. I'm curious to check. Videos, right. Atcoder, this is the current one, will be longer than 2 hours. 3 hours, 3:30, 1:40. I think I was busy then. 2:30, and it was only a single problem. 2:30, 2 hours, but again, only a single problem. 1 hour, well, right. Again, a single problem. I get less than 2 hours only when I try a single problem. By the way, I thought that today I will just solve D. I expected this to be a very difficult problem, but well, it went okay. Never get bored. It's not about getting bored, it's about doing other stuff too, including both work and relax. I can watch a movie, I can work on something else, prepare some article. I need to give people entertainment. I don't think that Atcoder streams provide entertainment. What do I want to do? No, let's actually create vector of pairs for edges. Let's call them input or list edges. This name. The advantage of this is that now I can nicely iterate over edges. First in list edges. And for everything else, I want to get a tree after this first contraction. Also, I need to think for like 2 seconds before I say contraction because I'm not sure what that word is. Have you done Advent of Code Day 13 Part 2? Yes, I did, and I prepared slides for the video. I don't know when I will make it. Soon. But I ended up doing a video on Chinese remainder theorem instead of making a video particularly about the Advent of Code problem. Let's go through all the edges again. If it's exactly this one, continue. Otherwise, say that we merge B into A. If first is equal B, E first equals A. A changes into B, and then we do edges in both ways. That remember edges. It's clear. Should I say that everything is from 0 to n minus 1? I think it will be nicer. Instead of 1 through n, 0 through n minus 1. Indexing changes a little bit. B does not exist. Also, I should do something like value of A. NAND equal to, there is no such operator, value of B, and then I need to retrieve this thing. We remember value of A. Unless there is maybe there is one. I wouldn't be surprised. Is there? NAND? Value. Nope, NAND doesn't exist. Then let's make a function. I know I could just type not and here end, but function is nicer, I guess. Oh, should actually be for Boolean values, just true and false. Is Andrei Tarkovsky popular here? Who is he? Then what? Some kind of DFS? DFS on A. Well, DFS gets a parent. A is the root. DFS will return DP. I can make it global too. Of size n by 2. DP of vertex, the number of green taken vertices, and whether there is not taken 0. Then parent of this 0 must be taken, and by this I mean I care about the last situation just before I take the last 0, because then this last 0 will give us 1, and then parity of the number of remaining ones will matter. Green is important because it actually gives us the number of not taken values. Maybe this should just say how many numbers are not taken, but whatever. What about about my interview website? Yeah, like we are doing this very slowly. Sorry about that. It will be done when it's done, so no updates now. No, I'm doing too much stuff, including something related to Code Chef or this IY preparation. Soon there will be Petrozavodsk, and also I'm thinking about participating there. I actually should sit down, abandon like a lot of stuff I'm doing and just focus on one thing, and then I would do it properly. At least I'm doing these streams. I think that's nice. I'm happy that I got consistent here. So DFS on B will compute this for that vertex. And then what? Well, we need to initialize in some way. Maybe not. There is kind of my DP, let's say. This will be merge of all my children. Then green 0 and 0 is 1. There is one way for that. Then for my green, should I mark it as NAX or something like that? Maybe let's also have a subtree size. This will be helpful, maybe not. Subtree of A is 1. So this just denotes subtree size. Right, so for his green, for my green, up to subtree of A minus before this thing happening. His green how many elements we take from his subtree and from the other children, and whether this my 0 in 0 or 1, his 0 in 0 or 1, if both are true, then continue, because that's not allowed. Only once I can have this situation where this is true. New FTP. This plus equal what? My DP times his DP. That assuming that those are non-empty. I think I already told you today that if we do continue whenever some situation is impossible, we will not deal with out-of-boundary errors like here, because we will only touch really possible states. All right, new my DP. Yeah, I didn't create that. This should be a vector. Should I really make it nice and use proper size? Maybe. This is initially just 1. New DP size subtree of A plus subtree of B, I believe. Comma. This is two-dimensional array of size this by 2. I will do some stuff there. Then DP is new DP. There should be obviously modulo here. For now, I don't want to bother. If I do this, compiler will every time give me warning that this is basically to do. What's your biggest CP price pool you have ever won? Around $20,000. But that was a single time. Second best was few $1,000s. The big prizes, there used to be big prizes around 10, 15 years ago. It was like $100,000 for the first place in Google Code Jam. Yeah, 20K is nice if you live in Poland. It allows you to live for several years. I will talk about it one day on YouTube. You know, a video how I won $20,000. But it was a competition by PaySafe, some banking company. Yeah, Google wants to work for them, so they don't give that much money. That's also my theory why prices decreased so much. So a winner wouldn't be set for his life. Right. For now, I do nothing with I don't check values at all. There is this condition about green. What do we do? Oh yeah, I know what's missing. After all of this, I combined all my children into one. And now I need to kind of update my DP into basically this kind of DP. And to make it even nicer, let's just make this return DP of size sub3 by 2. Should this be global? It can be. Here's DP. Now it's wrong to do return my DP, because as in almost every 3DP, there are kind of two steps. When you have several children, each of them with their own subtree, one step is to merge those into a single subtree. So now I have something like that. It represents this kind of merged thing. But now I need to also consider this guy to change from this red subtree to this yellow subtree. And there are some conditions here. What are the conditions? Oh, and binomial coefficients. I forgot about them. So what I wrote so far isn't complete for two reasons. But let's start with this. When adding root of this subtree, if this is, if there was any zero here, at least one, then I need to take, including this case. If there were only ones here, but I am a zero, then it's allowed to not take me, just there will be 1 as the second dimension. Sub3 of b, shouldn't this be up to smaller than? I think it should. Then it's a bit better to do this. Sub3 is initially 0, so without the root vertex. Every size needs to be +1. And then this makes sense. Right. And now I actually add myself, the root of the subtree. Polish minimum living wage. Somebody checked. $750 sounds about fine. I need to get some water. You see, this is what happens when I stream for more than 2 hours. It's all your fault. You told me to solve a problem. And now I need to do it. No other choice. This will be the final DP. Size subtree of a plus 2 this time. I want from 0 to subtree of a plus 1 by 2. Always in C++, this means two-dimensional array of size this by that. No pain, no AC. Exactly. That's what I'm always saying. No pain, no AC. My slogan. We will move from DP of green and maize. If it's 0, then continue immediately. And otherwise what? I can always take this vertex. There's nothing wrong with that. And when is it okay not to take it? Only if everything below is zeros. In this case, I can say new DP of green and maize. This is for sure 0 then, because it's if there was no 0 in the subtree, then it's not that I could not take some 0. And here, if value of me is 0, then this becomes 1. Just need to check this. What's the easiest way for that? For every B, run DFS. If there is any, no, if there's any 1, any 0. Any 0 of B, any 0 of A is true. What? And if everything below is 1s. So if not any 0, then I'm allowed not to take myself. That. Also. We're almost done. Because now this needs to be actually done modulo, but it isn't necessary for 2 first samples anyway. Though I'm of course scared that the first 2 samples mean nothing, just 0, 1. I could implement rand modulo 2 program and it might get accepted on those 2 samples. What problem which you solved did you consider to be the hardest? One of Petrozavod's problems for sure. But I don't remember exactly, and well, I would need now a few minutes to tell you the statement, so I don't see how to answer that really. But when you go to ICPC camps and you solve some very difficult problems, you sometimes spend more than 10 hours solving them. They are just very hard. Binomial coefficients, let's do that. This will just be this. Later I will take this modulo too. This is binomial coefficient. Binomial coefficients can also in some other way be checked for parity, but I don't need that. All right, something is then returned at the end. And how do I use it? I think the parity of ones will be important, right? Also, there's a case where everything is ones, and there isn't a single zero. I think I will care for every green. We'll care about this. This is number of ways to choose something except for a single zero. But its parent is taken. Then I take 0. High signet. I take 0. So the remaining ones are n minus green minus 1. So are taken vertices, and this is that last 0. Actually, the number of vertices in a tree is n minus 1, because we already contracted a single edge. It's that many minus 1, right? That many times will NAND something with 1. Wait, what? Does it actually matter? Yes, it does. When we have 1, 1, we'll get 0. When we have 1, 1, 1, we'll have 1. 1, 1, 1, 0, right? This is 0 with that 1 with that 0. All right. This is ones. Do we count root? Okay, so those are ones, but also I have my self value. After taking the last 0, this is 1. Value in the root. In this case, I have 1 at the end. Still, this should be taken modulo 2. But I'm quite done here. This is bad. And yeah, here I got the same answer. This shouldn't be like that. And here I will get overflows, right? Yes, I do. I was lucky enough that even though the answer should be the same, should be different for first two sample tests, my program prints the same stuff. So my program doesn't distinguish those two, which is obviously bad. In both cases, it says that if we first shrink 1, 2, then it's odd case. Well, it won't be hard to draw. Sorry, I'm hiding chat for some time to draw. Later I will display it again. 1, 2, 3, 4. In the other one, we will have 1, 2, 3, 4. And also the values are different. All right. Well, let's analyze what happens. When we do this, this is 1. Then we can do that for a 0, and then with that it will be 1. Or we can do this for a 1, and with this it will be 0. So indeed, this has one way to give us 1 at the end. Right, what about the right case, the second sample test? 1, 1, 0, 1. And again, consider doing this first, you will get 0. And then if you do with that, you will have 1, and with this 0. And that's, I think, the only case we should consider. Right? So something is wrong in the second test. It shouldn't say 1, it should say 0. One, two, two, three, 1, 1, 0, 1. Okay, some debug. We consider contracting this. Yeah, this sounds fine. What do we have? They say that there is one way that green is 1 and some 0 is not taken. Well, that's good because we have 1, 0, 1. I need to check. We have 0, 0, 1. We have this tree after the first contraction. There is one way to take this, and that's exactly that. Okay, cool. Then they say there is one way for 2 green, that would be this and that. And then this is not taken. The one way for that where a 0 is not taken. I don't see how. This value is wrong. This should be 0. And then there is one way to take everything. Yeah, this value is wrong. Nice to see you for the first time. Well, nice to see you for the first time, Gorav. Andreas, you're the reason I became interested in competitive programming. That's great. Competitive programming is a very nice way to train your brain, practice programming, code faster, make fewer bugs. Let's do some more printing. Also, I will here break just to avoid computations and printing more stuff. Right here, print A and DP. Remember that everything is shifted by 1. 0 has child 2, 2 has child 3. 3 is just this guy with a 1, and it says that we can take, can we take 0 vertices? Yes, sub3 is allowed to say that. If you don't take yourself, then also nothing below can be taken. This is case of taking, and this, okay, so this is bad. It's not that if I took some counts from children, then I can not take myself. Nope. It's like this. Not any zero below. Then what I can do is new dp of 0 plus equal, well, 1, because I don't take anything from below. Isn't this what should happen? All right. It's different now. But won't I get actually the other way around? Won't I get here 1 and then 0 in the second test? What do I need to count? I want 1 at the end. Starting with this. I think I need to consider the other cases, right? Right? So some more cases. Let's forget about this. When I shrink this, I will get 0. Then doing this in any order will give us at the end 1. And there are two ways to get 1. So I would say that this second printed value should say 2, because right now I don't take any modulo 2 here, and it's not that because of symmetricity I cut something. And this is pretty suspicious. Why do I get fewer vertices here? Is 3 smaller? Shouldn't I get always 3 vertices if there are 4 and 2 are contracted? Do gaming stream someday? From time to time, once every few months, I will do something like that. I don't like my number of edges. Oh, yeah, B changed into A. This was a mistake. Now it says 2. Cool. This is 0. That's bad. Right. The first test, I think, correctly will give us even number in total, but something is wrong with the second test. So let's analyze the second test. Second one is a chain with values 1, 1, 0, 1. No. What happened there? This was 0. With that, it must be 1. With this, it must be 0. So for this case, it's 0. Right. Now, what if we first shrink that? This will give us 1. Then no matter what we will do, this will be 0. And with that, it will be 1. I think that this second value should be 2. It should say 2. And then finally, for this you will get 1, with this 0, and with this 1. the output should say 0 to 1. And it says 0, 0, 0, so something's wrong. Let's analyze that. This refers to it. So when we had this, that changed to 1. Oh, this is the case with all ones. I just didn't implement it. Right. So if not any 0 of A, I need to do something. If 0 of A. All ones. Then I just check parity of that. And any order, but actually do I care about the number of ways? Should I maybe just take TP of green? This will give me the number of ways to eat everything. I would say it's just this. Zero to one. 1 to 1. All right. Let's add modulo everywhere. Oh, this was already done. Bum, bum, bum. Here I don't care. I don't want to print so much. Do I get any random errors? Nope. Then it's safe to do this. A lot of zeros. Is the answer 0? Well, it is. But then it's a very weak sample test. And I claim that just enough to do this. Fingers crossed. I would say 30% that this works. Check on YouTube. What? Oh yeah. Whenever somebody asks about resolution, please use this command. It will give you a link. Damn it, wrong answer. No. Oh, somebody has a nickname, Erichte for President. I thought it's just a comment. I passed half of tests. What about that? Hooray. Right? Well, now I could implement a brute force, but I don't want to. I remember how last time I took Omnix solution for some problem and it failed a single test. Copy. Okay, didn't look. What else do I want to do? This didn't look. Compile. Cool. Now I need a generator or small random tests. And from 2 to, for now, 4, let's say. I'm generating a random tree. And random binary sequence. I have some bash script. I want to test f against his program. I found this is a counterexample, really. Well, if I merge two ones, I will get a 0. So his program is correct because he says there is no way to get a 1. All right. That's at least an easy test to analyze. For a single vertex, its value should be 0. And what's the new DP? How do we have 1 here? They say that taking 0 elements is possible and there will be some missing 0. But I need to take this element. So this is a counterexample only for n equal to 2. If they're all ones. So what if this is like a single 0? They don't take it. I would say that green must be at least 1. Is that fair? I need at least the root. What spam is this? Oh, come on. Do you want a ban? Okay, removed. So now I pass all tests with n up to 4. Let's move to n up to 5. Yep, found a counter example. Let's draw it. We have 1 has a lot of children. And then 2 has a 5. That's a test. His program says 0, my program says 1. And there are a lot of cases to consider. What happens if we first shrink this guy? If we do so, we will get a 1. And then all of that will give us 0, right? 4 ones. That's easy. So the first answer should be 0. Then the second edge is this one. This will give you a 1. And now what are the possibilities? Well, First possibility is to eat a 1, then this is 0. Oh. Then with this one it's a 1, and with this one it's a 0. So this didn't count because we got 0. Then if we do this, it's a 1, and then there are two symmetrical cases. With this and then that, you get 0 and then 1. So I would say that the second value here is 2. Still even, but it's 2. Right, then we have this. This was symmetrical to this one, because those are two same elements. A 2. And finally, if we shrink this, this is 1. Then the next thing must be to shrink with this guy. It will be 1. And then we have two symmetrical cases, but I think both will give us a 0. I think that my program should say 0, 2, 2, 2. I want my program to print those answers. Actually, I might not see 2, 2, 2 because I started already moduling with 2. It said 0, 1, 1, 1. I think it should be 0, 2, 2, 2, or 0, 0, 0. Maybe the last thing will be easiest to consider. I think so. This is a case where I'm hiding the chat for now. 2 and 5 are merged first. They become a 1. Then merging with this must give us 1. Then we have 3 ones, but there are two ways to deal with that. What do we have here? We have two ways in total, and this claims that there is one way such that 0 will be not taken. Well, the 0 is here. You can take one element and not a 0, that's true. You can take two elements. What about taking those? This is strange. One way, okay, for 0. So for this subtree, it should be this line. There is one way to take nothing and be without a single 0. Fine. One way to take one thing, two ways to get this and that. Cool. Yeah, this is correct. Oh wait, there's also one way to get all three, isn't it? Like this value should be 1. Yeah, I think I'm missing a single value. Maybe in some for loop I have too short interval, like by 1. Other than this, I want to print. Do I want to print my DP? So already for children, I don't consider the fact that there will be 2 of them. But this should be 1. Merging those two should give me 1 here, exactly there. And this is even before checking the parity of my value. Also, do I clear everything? There is any 0 and subtree, but here I initialize. So yeah, I will not use all the values. Are you happy with one node? I might use it too. I don't know. It's very specific. It has its own bugs. For sure, it's not that I recommend it. It's fine enough for me. That's it. At 2 and 3, they both return this. Now we merge it. For some reason, we don't have that. Subtree of A. Subtree of B. Initially, this is 0, then it will be 1. For every my Z. For every his Z. Oh, there's that, right? I can do in one order and the other order. So this should be 0, right? Would it work just with simply without that? I mean, I don't think that this is what should happen, but just for a moment, experimentally. The answer is still 1. But will the p-values change? Yes, they do. This apparently didn't affect the answer. I think we need that, right? So there's one way to do this and then that, in the other way to do this and then that. Yeah, fine. This is confusing. So am I still wrong here then? Oh, I need this. Then I take a root as well. I have a 1. Then there are two ways. This then that, or this then that. So what do we have here? New DP. I'm looking at this line. Let's not print my DP because now it's just too much stuff is printed. We're looking at this line. We compare it with a drawing. We can just take this vertex and say that 0 is not taken. There's one way for that. There's also one way to choose this one as well. Then zeros, okay, right? Well, what's important is after taking this, we have that. All right. It's not that the number of ones matters at the end, but the number of ways to take them, like going top down. Right. So when I'm done with green parts, I don't just care about the number of ones in red parts. I want to know in how many ways I can now, after taking a 0, progress like through red parts. So I only am interested in cases where the number of those red ones is odd, counting also the root. And then I care if the I want to know if the number of paths through them, ways to propagate with green, is odd. So the definition of DP will change a little bit. I want to say that green part also eats all of this. Just later. So when merging two children, and they have those green parts and the yellow parts, I know that the green will merge with green, and I use binomial coefficient then, and then much later yellow will merge with yellow, like red with red. This is separate binomial coefficient. Right. Right. There's also a case of not taking an element because it's a zero. What then? I merge this subtree with this one, and there is a not taken zero here, and all the ones. Then I just care about binomial coefficient between ones and ones, like without this zero. I merge those, I merge green. All right, this is a quite easy fix. Red one will be, or his red, subtree will be minus his green, minus the fact that he has that special zero. And my red is same, all the same. And I believe we need to do this. Let's try again. The answer didn't change. And it is exactly this last case when it is still zero, it is still 1 instead of 2. I passed the samples. Well, at least only this case, at least it doesn't work for the case we are drawing here all the time. Did something change in this DP? Still it says that there is one way. It shouldn't know that there is one way. I expected this to be doubled because of this thing, the red stuff. Like now, when we merge those two, even in merging those cases, there's one way here, one thing there. I wonder if I count red properly. Subtree size and this subtree size. If zero, then don't count it. What? Maybe I need... Okay. This is new stuff. I'm copying this. And what happened earlier gave me that. Is there a difference? There is here. But not there. Here. So the case where we paint one element, and then those two we do not. All right. I say at least see what changed. We're close. I think we are a few minutes away from accepted here. It's taking one element. This is taking 0 and saying that 0 is not. But this should be do we have any merging there? No. Oh yeah, I need to print the temporary DP. Come on. This 0 elements. So after there was a 0 and it has 2 children, both are 1s. After I merge 2 1s, I see that everything here is even. Oh, this thing. If there wasn't any 0, this shouldn't be 1. No, this is product of some stuff. This is taking 0 elements. Right? Still wrong. I think actually on this is faster than previously. Maybe it doesn't work for some smaller tests. Yep. I messed up. Then before analyzing a test, let's see what I really did. This part I understand, but this one... Oh, not new DP. Of course not. This is my DP. Okay, works for n up to 4. And doesn't work for 5. Isn't it the same test? No, it isn't. Slightly different. It passed, but yeah, that one was, I think, 21. All right, do I want to continue this? It's so hard to decide. Wait a moment. Oh, I think we will need to stop now. I really planned for 2 hours, and this is what happens. Well, let's try to be quick with drawing that. One zero one one zero. Right. Right. If those two are merged, then we have 1. Then we need to take this. It's a 0. And then if we start with this guy, we get 1 and then 0. If we start with this one, we have 1 and then 1. So it's a 1 for this first edge. Then we need to consider this. This gives us a 1, and then we have 3 children, like that. If we first go for this guy, it gives us a 1, and then there are 2 1s, but I can make them in this order or in this order, so it's even. And generally, well, this must be even because of this symmetrical case. Whichever you take first, you need to take the other first. So I claim it 0. Then, yeah, what about taking this one? It gives you 1. Then it's 1, 1, 0, 1. Right. If we do this, that's a 0, 1, 0. If we do this, that's a 1. And then there are 2 symmetrical ways, so it's 0 in total. I think it's 0. And finally, oh, actually, that was up to that was the last edge. Here, still, we don't know 1. What about edge from 3 to 4? This is 0, and we have 0, 0, 0, 1. What do we have? If we do this, that's a 1, that's a 1, 0. If we do this, that's a 1. Then with this 1, with this 0, 1, this 0 with this 1. I think there is 1 here. This was 0, 1. I got that. But I don't remember what the 2 programs printed. Oh, actually, his program disagrees, so I got something wrong. Let's print every single answer. Oh, that's dangerous, because my program printed the same thing that I got here, 1010. Oh, let's go again and try to... Can any code versus red get into MIT? Oh, you're back with your questions. No, not ever. Algorithm isn't everything. So, I need to mute microphone because there will be some noise. But yeah, I will just go again through those 4 cases. All right, the first case seems all right. No, unless it isn't true that we start from some edge and then we treat this as the root. Maybe my solution is just wrong. And that would be a disaster. Then this. We have a 1, then 1, 1, 0. I said that it's 0 because of the symmetricity here. Whatever you do first, you could swap the order. I still claim that is true. Right? Like, there must be a mistake here. Please tell me what's the mistake. And then the third one is this. This will give us 0, then there's 0, 0, and 1. That's the tree, this is the root. If we start like that, that's a 1, 1, 0. So we don't count it. That's a 1, and then 1, 0, so don't count it, or 0, 1, count it. Hence a 1. Right. And finally this thing, it's 1, 1, 0, 1. Either 0, 1, and 0, so we don't count it, or whatever happens here and then symmetricity. I don't see a mistake. I know what I should do. I will actually shrink this by hand, plug into a program, and ask a program what should be the answer. If there are 4 vertices, I have a drawing on the other screen, and now the edges are 1, 2, 2, 3, and 2, 4. Values are 1, 0. This is set to be 0 in total, and that doesn't seem right. This is exactly the case of contracting the first edge. If I contract the first edge, I thought that the answer will be 1. If I contract this, I will get this tree. 1, 1, 1, 0, and this is what I plugged. Wait, 1, 1, 1, 0, maybe I did something else. No. Yeah, this is exactly it. And now the programs agree that this should be 0, but I got twice 1 when analyzing this. Oh, because I want to say that this is the root. Okay, so I cannot run a smaller test like this. Damn it. I don't see it. Right. If you tell me like which case is wrong here, then I will keep investigating it. But if not, then this is the end of the stream. I'm going way over the time. And we'll get back to this next stream. Maybe I will just post a short video on this on second YouTube channel if I find a mistake. This is a case with this being the root. We eat this, it's a 0. If we eat this, it's a 1 with this a 0. If we eat this, it's a 1 with this a 1. So odd number of cases. Yeah. Maybe there's something wrong about taking an edge and saying that this is the root, and now everything will be taken starting from the root. Yeah, all right, let's finish this. But I'm very curious what is wrong here. Thank you everybody for watching. After my Atcoder streams, I don't rate channels on Twitch just because these are very difficult topics. So there is nothing really similar on Twitch. Nobody on Codeforces is streaming right now. So thanks for watching. Bye bye. See you Thursday.